Yeah, let's get started. Everything is code, a polyglot adventure. Maybe the right thing to amuse you after the heavy lunch break. My name's Leander, and yeah, I'm happy to be here. I'm happy to be your host and happy to give this session. A few words about me. So this is me, Leander. I'm a chief technologist and principal software architect. I do work for QAware. We are a small software project house located in Munich and in Mainz in Germany. Me myself, I do work for customers like Allianz, BMW is really big in Munich, so this is a big customer of ours, and we do, well, custom software projects for them, right? So yeah, senior developer and architect, a cloud native nerd. I had 2 hours ago the Hitchhiker's Guide to the Cloud Native Stack talk. Open source, greatest invention ever, yeah. Now, what's this all about with this talk today? And I think it had a quite funny origin. It was right after the lunch break, and we were all standing around the table and, well, drinking coffee, all the developers. And what do we do when we have lunch break? We rant about the other people's technology. Yeah, my editor is better than yours. You need to use Emacs. I use Vim. Is the Emacs user here? No Emacs user. Well, I know Josh Long asked this yesterday. If there's this one Emacs guy, he always follows him. No, so, so when we talked about that, well, we did talk about programming languages. And then this one guy said, oh, have you tried Kotlin? Kotlin is the greatest. And then the other one, oh, no, forget about your Kotlin, you know, Python, best ever. Then I came, you know, as a gray hair. I said, yeah, all those fancy new programming languages, you know, Java, still the best. And, well, off we went. We had a good chat, we had a good coffee, and then we went off and everyone went to his project again. But something in my head kind of continued, and I thought, well, which programming language do real developers use now? Which one's the best? Anyone here who thinks Java's the best programming language? So little. JavaScript? You're wrong. So, which programming language do real developers use? So let's see. So end of last year, there has been this hashtag here, first 7 languages. So those are mine. Pascal Basic, C, C++, Assembler, PHP, Java, and C#. So hands up, who has programmed in at least one? No, all of you, right? 2? 3? 4? Wow. 5? That's good. Now it's getting a little thinner. No, Turbo Pascal was my first language. Was my ever first language. I had my first programming job with 15, and I did program printer drivers in Turbo Pascal. Well, most of them are probably not so state-of-the-art anymore. So even more interesting would have been this hashtag, okay? What are the last 7 languages I used? So those are things like Java, Groovy, TypeScript, Ruby, Kotlin, Scala, and recently I decided to give Go a try. So hands up, who has used at least 3 of those? 4? Not so many anymore, 3 hands. So those are like the new kids on the block. And let us explore some of these, maybe. Not all of them, but some of these. Now, of course, you can do research differently. You can look on the web, and you find different indexes which tell you what the most popular programming language is. So this one here is quite recent. I took this screenshot only a couple of days ago, and well, Java is currently definitely the most popular language, according to this index. Followed by C, but for some reason C kind of had a huge decline here. And, well, the rest is somewhere here, well, pretty close up. Now, you can have a look at another popular index. There's this one here from RedMonk. And what they do is they try to correlate the popularity based on languages used on GitHub and those things. So here's ranking on GitHub, and here is questions on Stack Overflow, right? For the Stack Overflow-based development. So those are is a good index. And if you look here, well, it's JavaScript, Java, C#, PHP, Python are pretty high up here in this ranking. Well, you can look around as long as you can, and well, different data, different opinions, different languages, different people asked. It's like always with statistics, you can tweak them a little, and suddenly Python is the most popular. So you do not find a unanimous opinion on the web. Well, never mind, right? We make our own opinions. So you might already guess it. Of course, there is no best programming language, okay? It always depends on the context. It always depends on the specific domain you implement the software in. And then maybe there is a better choice for a programming language than maybe another one. And so let's dive into this domain thing a little. Now, we always compare ourselves with craftsmen, right? We take great pride in the things we implement, we take great pride in the systems we develop, and we put into production for our customers. And the IDE is our workbench, right? And if you take this workbench metaphor, you have a toolbox, and in those toolbox, you hopefully not only have a hammer, yeah, to fit on every problem you need to solve. I mean, hopefully you have like 3 different hammers and maybe 3 different saws for different types of things, for different domains you want to implement in, okay? So different sharp tools to get things done. So this is our workbench. And I want to introduce you to a term which, well, we call software industrialization. And when you think about industrialization, at least the early industrialization, you might think about dirty factories and underpaid people working there, okay? Supposedly that's in some countries so, but I think this would be software slavery, right? Now, I'm talking about a high automation, not about cheap labor. I'm talking about high automation of repetitive and laborious tasks. I mean, we developers are great in this. When we do the same workflow the 3rd, the 4th, the 5th time, what do? Well, maybe we write a small script, okay? We automate this because we don't like to type all those commands in every time again. You do mistakes, then things break. So, well, we write ourselves our tools. So I do think that you can achieve better software quality in the end through a standardized and streamlined toolchain throughout your whole team. In the end, I think a well-integrated tool chain can lead to higher productivity and also happiness of the developers, right? Only a happy developer produces good code. That's that. And in the end, we are a software project house. You probably work for one as well. In the end, it's also about cost efficiency and competitiveness, right? You need to be better, or you want to be better than your competitors. How do you achieve this? Well, you optimize the way you work. Okay, so this is the idea of software industrialization. And I think software industrialization is becoming more and more popular. It only has a different name. You all heard about DevOps and continuous delivery, right? And I think software industrialization is a key requirement to do successful DevOps and to do successful continuous delivery. You need to automate. Yeah? There is always the developer, but you want high automation. Of course, DevOps and continuous delivery is also about processes and changing people, but also about tools, and this is what we want to focus on in this talk. So here's my bold statement. Software development means everything as code, as much as possible, okay? And when I say everything as code, I mean everything is made from code, right, the software, and everything is made by code. So all the surroundings, the tools that make the software, okay? And if both are true, then you have pure software industrialization. Who knows in which programming language this is written in? Very good, thank you, Kotlin, excellent. So let's go on. So what did I do, okay? So I kind of fantasized a little and thought, okay, let's go on a quest for an ideal project archetype. I thought, okay, assuming I start a new greenfield project for some unknown customer, which technology would I use, okay? Well, what did I do? I went through all the departments in our company. I talked to the lead architects and said, like, if you could name me one technology which you think is the coolest, is the most efficient in your project, what would that be? Okay, so I talked to the UI guys, I talked to the backend guys, I talked to the more infrastructure-related guys. So what is the language or the framework or the tool that is most successful in your project? So setup, build, coding, testing, CI, infrastructure, documentation, you name it. And then I kind of mixed everything up, plus a bit of wishful greenfield thinking, and there I had it, well, maybe the, for me, very opinionated but ideal project archetype. So let's get started then, right? So let me be your Frodo, yeah? And I will take you on a polyglot development adventure now, and I promise I will open my IntelliJ soon, and then we do some coding. So, SEU as code. We start at the very beginning, assuming we have a new project. So, we call this lightweight developer provisioning. Now imagine, you start this new project, you have 20 people there, and you need to get them started real quick. I mean, how much money or time do you want to invest that those 20 developers set up their machines right? Write JDK, write IDE, write app server if you're still in an app server world, write local database, etc., 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 right? So how fast can that be? And I tell you, I think it can be within 10 minutes for a 20-people team. So SEU, bit strange, is a German acronym, stands for Softwareentwicklungsumgebung. Never mind, replace SEU with IDE. Yeah, it's not very international, this acronym. So this idea was, well, we use a build tool to automate the creation and update process of our software development environments. And the choice I picked back then, 2 years back then, was Gradle. Gradle been on vogue, so I figured, okay, if Gradle can build anything, well, let's see if Gradle can build me my software development environment, and it can. So the idea is simple. Software packages are modeled as dependencies. Gradle tasks and Groovy scripts replace my shell scripting I have. The definition of this software development environment is version controlled. Super important, because I can now go back and forth in time if I do a patch or if I, during the lifetime of my software, of course the software changes, but also the development environment changes. So this is super if I can version control this definition. So this is what it looks, but this is the time to, well, switch to code the first time. Okay, how do we do that? Well, we think that no developer should install the software really locally under C programs or wherever, locally on his file. So what we do is under Windows, we use a virtual hard disk, or under Mac here, I will be using a sparse image file. So this is like a file system container, if you like, okay? It's not a Docker container, but it's a file system container. And if you delete this container, all the software is gone. I mean, you can copy it to a colleague, for example, for quick setup. So, I show you, well, it's everything on GitHub. You can try this on your own. So let's go to GitHub, and what you can do here, I have this archetype here, which kind of gives you a quick setup possibility. So this is a zip file you can download. Yes, network is working. You download the zip file, and I've already prepared this. So I've prepared a sparse image file. You see that here on the left-hand side, everything is code. And I've extracted the zip file into this directory. So this is it here, right? So add project folder. We do that. Open. So here you have the definition. And as you can see here, those are the software dependencies I talked about previously. So what I want to do here is I want to install Maven, I want to install Groovy, I maybe want to install JRuby, and a Scala SDK, and whatever software you think you need for this specific project. And then you open a console. You go to volumes, So here we go. I say Gradle U, bootstrap SEU, and what it usually does now is download the software. We have all our software packages in the different version in our company nexus. So we have the versions always there as a pre-built package. Because I did this already once to prepare, nothing is downloaded because everything is locally already in the Gradle cache. But if you go back to this Explorer now, you see that something changed, right? We have a kind of a, well, convention over configuration. We have a standard layout, a standardized layout of the project, and this is how all our projects look like. No matter if you're developing under Windows or Mac or even Linux. So this is what it looks like. We can open a new console, and just for example, I have, what's the version called for Scala? I don't know. So I have installed Scala 2.11.8. If I do open another console, nothing is found, right? Because my system itself does not have Scala installed. It's only within this environment. And this also makes it possible, right, to develop on 2 or 3 projects in parallel, each requiring different SDKs or whatever. Now, if you go in here, you do that. If you do Gradle tasks, so this is all the tasks I have. So for example, what I could do is, well, Gradle U, click clone all. What this does now is clone the source code into this environment. So I see here, source code is being cloned, nothing there yet, should be in a second, and there you go. And this is the way we work. Now would be the time, version control this, add to your version control system, and then all you need to do over time is always edit this Gradle build file and add new dependencies and add new tasks, for example, to initialize your test database, for example, or to run your load tests, or build your Docker images. All this can be all put into this Gradle build file for your software development environment. Right. So that's SEU as code done. Now, we go on further. We want to build our software, right? And before I skip to the next slide, who's a Maven user in here? Who's a Gradle user already? Wow, that's not that bad. Okay. Now, it's always good to rant about other people's technology. I said so previously. But Maven is good. I've used Maven 1, Maven 2, Maven 3. 80% of our projects, 90% of our projects are all Maven-based, and there's nothing wrong with Maven. Kind of. Okay? Only that Gradle is about 100 times faster. Hey, and that's a fact. Gradle 4.0 just been released, and they have, big figures, and I trust them that they're true, and they say for large multi-project builds, they're 100 times faster. And, well, when we are starting to migrate some of our projects, and definitely I'm sure that for new projects, I will not use Maven anymore. Because in a DevOps continuous delivery cycle, you want to be fast. You don't want to wait that your project is being built, and Gradle is that smart about what has changed, what hasn't changed, which tasks do I have to execute and which not. So it has this intelligent caching mechanism that basically tells you nothing to do, nothing to do, nothing to do, 30 seconds, done. Yeah? Maven is stupid. It just compiles everything, runs all the tests, and there you go, 4 minutes. And now think about, if your manager maybe asks you, well, why should I use Gradle? Well, then do the math. You say, well, every developer does 50 builds a day. Per build, we save, I don't know, maybe a minute. We have 20 people, and how much is a developer hour worth in your company, and then you give him the bill. And instead, you could implement features and not wait for your bloody build tool to finish. So I think Gradle is definitely the new kid on the block, and it's a sensible choice, seriously. It's very flexible, it can build everything, it supports polyglot builds quite nicely, so no matter if you Java, JavaScript, Kotlin, Scala, whatever, they have a compiler for everything. Succinct build scripts, so they're really short, a lot of conventions, incremental builds, reduced build times. Well, if you're really fancy, you can even implement your build scripts in Kotlin and not in Groovy anymore. Composite builds, really interesting feature for microservices, parallel downloads, etc., blah, 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 yeah? Frequent releases, it's mature and stable, and trust me. So this is what it can look like, for example, for a small microservice. In this case, I'm using Pereira Micro Edition, and there you apply a few plugins, the application plugin, War plugin, Kotlin plugin, Groovy plugin. So if you might wonder, how long does it take for a project to set up? And that's it. You have a Gradle project. You have a Gradle wrapper, and that's your project set up. So really easy. I know Maven has the archetype mechanism, so that's not really a killer criteria. But just getting started with Gradle, that's really easy. Now for the project I want to show you, well, of course, the Gradle build file. Well, let us see. Is that visible to everyone, even in the back? Okay. Well, otherwise we go for presentation mode. Always good. Okay, well, that's even better, right? I mean, you see here, this build is really doing a lot, okay? So it's packaging the application, it's building a Java application, it's building a WAR file. It produces a WAR and a zip and a tar archive. Do that in Maven, right? There's only one artifact per module. It can compile Scala, Groovy, etc. Here are the dependencies, nice and short, the dependency syntax. Here's, I execute the tests. This is how we define a distribution. This is like the equivalent to the assembly plugin in Maven. Here I have Docker, so I have, for example, a Gradle task that build me the Docker image. Kind of interesting for your CI build later on. And so on and so forth, and it's only 220 lines of code. If I imagine now the POM equivalent to this one, I don't know, 1,000? A lot. So give Gradle a try, right? I'm not being paid by Gradle, by the way, okay? Okay, main is code. Now, here's my bold statement. There's nothing wrong with Java as a primary language, and I still believe that. Even 20 years ago, okay? My eldest daughter, her name is Java. So that's how convinced I am, yes? And all of our projects still use Java. This is primarily due to our customers. A lot of customers, they use Java on the back end. BMW does, Allianz does, German Telekom does. They all do Java. So, and Java's fine, right? But there is a serious contender out there. And this is this one here, okay? Kotlin. I know there have been some Kotlin talks, and if you haven't been to one, I suggest you maybe have a look at Kotlin, okay? I think Kotlin somehow has the sweet spot between good old Java and pretty scary Scala, somewhere there in the middle. You know, you can read it, and it's easy to learn, so here's my argumentation for Kotlin, or not Scala, Closure, or whatever. I think it's easy to learn for a Java developer, and I've done it myself, and within 2 days I've been kind of, you know, up to scratch and could develop. This is why I have this here. The program that runs this thing here is written in Kotlin, and it was my first Kotlin POC. And it took me a couple of days, and that was it. So I think it's a well-balanced universal language with inbuilt nice safety, a lot of syntactic sugar, excellent interoperability with Java, with existing Java libraries, JDK 6 compatible, small library sizes. If you're an Android developer, right? I mean, Google just announced that they are considering using Kotlin for implementing Android applications. So it's a good IDE and tool support. So they have, of course, IntelliJ. I mean, it's from the JetBrains guys. But the IDE support is good, also in Eclipse, for example, tool support. Yeah, so there's nothing wrong with giving Kotlin a try. And now this here is, I show you the code in the editor, right? But this seriously is a microservice in Kotlin, a JE-based microservice. Up there, you have the data class. Nice feature, and I know it will sometime come in JDK 10, I think, as well. So you have here the data class book, and here you have the fields, and with this one line, you get so much, okay? You get hashcode equals toString, copy method, default constructor, constructor for all the fields, getter, setter, all in one line. Hey, and how many POJOs do we write? POJO X, POJO Y, and a bit of JSON annotation, so, okay, 2 lines of code. So I have this class here. Here I have a resource. And you might argue that, okay, this syntax may look a bit, well, unusual at the beginning. But it does work. So let's go to our IntelliJ again. Up. So here we go. Source. Main, Kotlin. So this is it, you know, different Kotlin classes. Here's the book resource. And I think if you look at this, for a Java developer, I would argue that this is, well, pretty much readable straight away, right? No strange syntax. Well, you don't need semicolons at the end, okay? You have fun books. This is here the type and the parameters, return types. So try Kotlin. And if you're more on the Spring Boot side, Spring Cloud side, you know there's this Spring Boot initializer Josh Long always shows that there you have the option to select Kotlin as well. So doing Spring Boot development with Kotlin, also a nice fit. Not only for JE. So let's run this. So where's my whoop, not here, getting confused. So first thing, Gradle you build, right? Remember, I have not changed anything. So that was my build, 1.7 seconds. Remember Maven, what Maven would have done. Gradle you run. Default tasks you get when you apply the application plugin within your Gradle build file. Come on. That's always the thing with demos, right? My time. Well, it will run, it will start. We give it some more time. And we continue front-end as code. I have to admit, I'm more of the back-end developer guy. Yeah, well, UIs are not my strength. As long as there's a button and a few fields, you know, UI is fine. So I went to our UI specialist and I interviewed him and told him, okay, dude, tell me, what's this JavaScript Wonderworld doing currently? What do I have to use in a current project? And then he went off for, I don't know, an hour, throwing loads of frameworks and you know, tools at me. And this is kind of the excerpt. So first of all, my first experience was it's a totally strange universe on its own, right? But my clear trend, single-page web applications. And they have their place, and so there is probably no way around of, well, getting used to this JavaScript Wonderworld. And maybe some fancy JavaScript UI framework. Don't know which one is en vogue. Angular 1, 2, Vue.js, Aurelia, oh, there's so many. But one thing is sure, HTML5, CSS3 plus the language. So what do you use? Do you use JavaScript pure? Or maybe you're like me from the back end, you like your types, you come from a strongly typed back end. So TypeScript might be a choice. Or he said, TypeScript, the transpiler is not the fastest. You should try ECMAScript 2015 plus Babel. And you need Node, and you need NPM, and you need Webpack. And I'm sure if I ask him the same question in 3 months' time, he will give me something totally different. So that's enough about JavaScript. So let's see. Yes, our service runs. I don't have a clue why it took so long to start up. Okay, test as code. Again, question. Who's from the JUnit Hemcrest Mojito fraction? Oh, okay, not that many. A quick shout from the audience. Who's using which test framework? TestNG. Okay, TestNG. Well, popular as well. I'd show you another thing which I think is popular, okay? I'm a total Spock fan. Not only because I like, Star Trek Enterprise, but I think Spock and Groovy are an ideal and perfect match for your general purpose testing. Unit testing, integration testing, UI testing, the whole test pyramid. I think this is a good choice. If you see this here, and there's so much in this, in my opinion, really expressive unit test, right? First of all, you have this behavior-driven style, given, when, then. That's the first thing. Look at the test name. I can use a string as a test name. I mean, that's awesome, right? And down here, I have something which Spock calls data-driven testing. I know in JUnit you have your parameterized, and in TestNG you have your test data producer or something they're called, right? And this does pretty much the same. So this test will run 2 times and inject the values which you see here in this test data table. And this is really neat. So let's go back to IntelliJ. Let's have a look at some tests. So I have those Groovy tests. I have the book resource back here. I can let that one run. So this is a normal unit test. Oh yeah, you see that here, the mock bookshelf. So Spock has already mocking built in. And I know, a bit hard to see. So those are the tests that got executed. Good tool support as usual. Okay, so that was a unit test. I want also an integration test. So obviously I have a REST endpoint. So how do I test that everything's working correctly? So this here is a combination of Spock and REST assured. So I can do REST endpoint testing. So this is more like the integration testing. And this now will call our microservice, which is running in the background. You see that here from the log output. And last but not least, our service also has a UI. I'll show you in a second. And you can also do interface testing, user interface testing using Selenium. So Spock and a framework called JEP is a real super combination to do interface testing. JEP, the framework, it has an inbuilt page object pattern. So basically what you do is you model all the pages in your application as a class, right, that describes each page. And with the spec, you can then say, when we navigate to the index page, then the index page is displayed and the headline is correct. Okay, and in the background, it does all the fancy Selenium automation and using HTML unit or a real browser to verify that everything worked. So that you trust me that the UI has a localhost 8080. Yep, see, that's the UI. And I said, I didn't do that, the UI. A nice friendly student styled this UI for me. So here we have a UI that kind of displays all the books which are currently in my book repository within my microservice. Now, another test which is missing in my opinion is load testing. And we do regular load tests in all of our customer projects. So here's a performance test and a tool which is well, we use JMeter a lot, but dumped it, not because of the UI, but because of scalability of JMeter. And we use Gatling nowadays for everything. Now, the small downside on Gatling is that you now have to use Scala or Scala DSL to write that. So here we go, next language. So now we have already Java, we have Groovy, we have Kotlin, and now we have Scala. But I think, well, it's not too hard to learn, and you, well, can implement Gatling load tests without knowing too much about Scala, right? I cannot say that I could implement any program in Scala, no way. So here, what do? We define, well, up here, we have the space configuration, we have a comma-separated value file with some test data, and then we execute different HTTP calls during 30 seconds. We feed in the data from our test data feeder, and then we execute the HTTP call to get the book by title. Then we pause 1 second, and then we get the book by ISBN and call that call. And down here, I set up everything. I inject 10 users at once for 30 seconds, and then I'll ramp up to 50 users over 30 seconds. So that's the test. Let's run this. So what we do is we do Gatling run. Up. So let's dress our little microservice a little. Yeah, I did a clean build before, and now let's hope it should start pretty soon. And when it runs, what you see at the top window, you see like the log output of the things it does. So this runs here, and so let this run. And I told you we use this for almost all our projects nowadays. And what we do is, well, we usually fire up a few VMs at Google or at Amazon, and then we do some really heavy load testing on well, the project I'm doing for BMW for the last 4 years. We're testing with 20,000 concurrent users. And we only need 2 VMs for this and 2 instances of Gatling tests running. And this is quite impressive. We couldn't have done that with JMeter, right? So let's see, we should be almost done. Now I get this test report. And if you want to see what this looks like, well, this is now a nice report. We have a few failed requests here. Here you have the distribution of how were the response times. You can see here. So I had a few errors. They were all 404. You see here the percentiles of the response distribution. So this kind of makes up a nice report you can then give to your ops people and say, look here, here's the report. We've done thorough testing. Off you go. Please put it into production. So we have to have that before we can put our software into production. And that's that. So give Gatling a go if you do performance testing. Right. Now, tested, everything done, pipeline as code. And again here, do all people know the feature, the Jenkins file feature? So what you can do is you describe your build pipeline. Again, the newer versions, 2.0 versions of Jenkins can do this as a Gradle file. And again, same thing here, as your software evolves, your build pipeline will also evolve, right? You start off with a really simple build, maybe 3 steps, and then your software evolves, and maybe you add a new step, and you want to generate documentation, and you want to deploy your software to an integration environment, and so on and so forth. So as your software evolves, your build file also evolves, and Jenkins will pick up this file and automatically alter the definition and the way it builds. So I've already prepared that. So here we go. Do that. Oh God, too many open windows. There we go. So I see that here. I spun up a Jenkins in the cloud using Google Cloud yesterday evening, so I can show you. And what you can now do is, well, let's go to here, view, presentation mode. Now we try to simulate some, where's the Jenkins file? Here's the Jenkins file. Hello DevOps Poland demo, hope you are fine. Okay, so I changed the Jenkins file now. I go to version control, Jenkins file, local changes, and I commit and push this. Commit and push, and now quickly we go back here. See, already building, right? And if we go here, print message. You see here what it's doing. Here's the DevOps stage. I go back. So where's my console output? Oh, strange. Where is it? Here. Logs. See, there is the change demo message. Okay. So you can introduce new stages and whatever you like. So again, as code, build definition as code. Right, so what's next? We've built everything. Now it's time to go for the infrastructure as code. Well, first up, Docker, 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 right? There is no project without Docker anymore, right? We all have Docker. So this is Docker here. Well, basically what we want to do is we want to containerize our application. We want to build a nice Docker image, and then later on we want to deploy this Docker image to some cloud environment. So what you have here is you have this Docker file, and you have this specific syntax. It's not hard to learn. Well, there's good documentation anyway. So you do that, and well, building the Docker image either can be done using the Gradle task, or what you can do is you say docker build -t some tag 101 and off you go, and that's it. Application containerized with the output of my build. So I have this Docker image now. What do we call it? Some tag. Up, and there you go. So it's a 174 megabyte image, which I could now execute. Or what I could also do is Docker compose up. Because usually what you have is you don't only have your microservice, you also need a database and whatever. So you describe this in a YAML file, in a Docker compose file, and well, you fire up everything. Good. So, Vagrant and Ruby, for example. Well, sometimes you need a full-blown virtual machine to do your work. Well, then the tool of choice in our company is Vagrant. You have this small Vagrant file, and with Vagrant you can spin up a virtual machine and provision it pretty quickly. And you might not be aware of it, but a Vagrant file is a Ruby file. So you can write any valid Ruby definition into this Vagrant file. So here you go, next language. Provisioning with Ansible, infrastructure as code. I mean, you want to define your reverse proxies. You want to install those. Maybe you need to install a Solr server. So for infrastructure provisioning, in our experience, Ansible works the best. Simple reason. In the environment where I'm working most is, well, we kind of don't have proper access to the machines, and we do not get any package installed. So if you have a tool like Chef or Puppet, you always need an agent on the target machine. And with Ansible, all you need is Python 2.7 installed on the target machine, and you need an SSH account. And this is really handy and really easy. Well, not much to learn with Ansible. You see this YAML file here. So that's a YAML file, for example, where we could provision the build job in Jenkins. It's quite neat. Cluster orchestration, for those of you who've been in my previous talk, well, currently cluster orchestrator of our choice is Kubernetes or OpenShift, where we want to deploy our microservice, right? Good. Now, are we done yet? Code is running, code is deployed in production. Are we done yet? Not quite, right? Documentation. Yes, I know some people are there, they say, well, source code is enough. Who the hell needs documentation? Well, unfortunately, I do have some customers, they are quite keen on their documentation. And writing those in Word is like hell. So what I want is some nice developer-friendly syntax, right? I want some Markdown, I want some AsciiDoc. I want those things, and the documentation should be as close to your source code as possible. So version control your documentation next to your source code. Same repo, different repo, but version control it. And use a lightweight syntax. This here is an example of what such an AsciiDoc document looks like, so not much to learn. Those are headers, for example, headings. You can quite easily include images, you can include source code, and so on and so forth. So for the people of you who are developing on GitHub or use GitHub, they are pretty used to Markdown, I guess, and Markdown is good as well. So give those lightweight documentation formats a chance. Again, AsciiDoc, J, and Gradle. There is awesome Gradle support, so this is all you need to include in your Gradle build file to have a good ASCII documentation. And if I do write articles for some German computer magazines, all they get from me is a Gradle project with AsciiDoc, which they can execute, and then they have an HTML or PDF output, and then, well, they can do whatever they like. I do not write Word anymore. Okay, well, time to wrap up almost, right? 4 minutes left? 4 minutes left. Good. So, architecture as code. Well, I don't know, that was, I think, half a year ago. I've been in a conference, and I've seen Simon Brown talking about Structurizer. And I was blown away. I thought, yeah, that is really cool. He's about, well, what are your architecture diagrams, if you have some, are they up to date or not? And with Structurizer, you can define your software architecture or draw your architecture diagrams in code. You can define it in code. You can scan your code base. So all your diagrams are always up to date. And I thought, hey, well, that's really interesting. I think it's not free to use for open source projects. It's kind of free to use, and for commercial, you have to pay for it. But never mind. I think this is a quite good thing. Another thing, what we do is architecture validation with a tool called QR Validator. This is an in-house product which we will open source quite soon, I think, somewhere in spring, not spring, autumn, the other word. So this is how you can model your components and define which component is allowed to call which other component, like Structure 101, Sonograph, SonarJ, those are commercial tools. This here will be open source soon. It's a simple Groovy DSL, and you can check this during build time. The fun part, presentation as code, I did those slides in Markdown. I thought, well, that's kind of a gimmick to do that. I don't advise you to do it for business presentations. That's quite tedious. If you like, you can do also things like this with JavaScript, but I'm not a JavaScript guy. Anyhow, wrap up. I think state-of-the-art software projects are polyglot. There's no way around it, right? And if you look at your current projects, you will probably find 3 to 4 languages already. So I think we software developers and architects, what we have to do, well, we have to use the right tool for the job, okay? And if Java is not a good fit to do something, then use the language which is a better fit, right? So this makes you productive, this, well, makes your tooling right. For those of you who say, oh yeah, thank you, I say get out of your comfort zone, right? Try something new, don't be afraid, yeah? Be daring, try something new, get out of your comfort zone, but of course be careful. If you wildly combine every hip language that is out there, I probably would say that your project is doomed already. Okay, so of course you have to make the right choices. And of course the right choices depend on the team, the project context, and your customer. Okay, so be careful here. My invitation is, fork this project on GitHub, make your own project. Make your own project archetype and experiment. Please vote for the talk, and thanks.